Very good morning to all. So in this class, let us have a discussion of error detection and correction mechanism in the computer networking. I hope in the fundamental courses of computer networking, you may have already learned about how the communication processes happened between the sender and receiver. Usually in the computer networking, we can call it as the transmission of packet is happen in between the sender and receiver, or otherwise we can call it as in between the two stations the data communication is happened, or the packet transmission is happened. So during the data communications, your transmitted packet may be successfully received by the receiver, or otherwise due to some kind of intermediate problems, it may not reach to the receivers at right level. So whatever the data we are sending from the sender side, the same amount of data without any loss, it should be reached to the receiver. So that is a main core idea behind that, the successful data communications in the computer networking. So if there is a problem, if there is a error is happened in such a kind of data communications, how we are going to detect the error and how we are going to correct those kind of errors in the data communication. Now let us move on to the first topic, that is a error. So what is meant by error, and at which place the error is happened, and how we are going to, which are all the different types of errors is happen during the transmission. So normally an error is a situations when the message is received at the receiver and it is not identical to the message transmitted. So for example, if I am sending the data as hello, good morning, then the same data have to be received by the receiver. Instead of that, if it receives as good evening, so there will be some kind of message variation is happen. So if it is an ordinary message, there is no issue. If it is a sensitive, very sensitive, or otherwise very important informations, then if there is a modification is happen in between the sender and receiver, it will create a major issue. So in order to avoid such a kind of problems only, we go for using error detection and correction mechanisms. So usually there are two types of error detection error is possible to happen. The one is a single bit error and the next one is a burst error. So single bit error, from the name itself we can easily guess that is only one bit of information is modified. So here from the receiver side and sender side, there is only one bit changes is happened. Here 00001010, but at the sender side we are sending the information as 0000 instead of 1. So that is at the sender side we have sent the bit value 0, but it has been changed to 1. So that is a single bit error is happened. So instead of that, if multiple number of bits is changed by compared to sender, the receiver side there will be a number of bits, more than one number of bits is changed, then we can call it as a burst error. So here this one is an example for that. So here you can see that there are 3 bits of informations have been changed by compared to sender. The receiver bits have been modified. So that is a two types of error is possible to happen during the transmission. So error detection techniques, the one is a single parity check, two-dimensional parity check, checksum, and cyclic redundancy check. So these are all the very important topic in your computer networking. So because the error detection and correction mechanisms, it can have a examples. There is a possibility to ask the one kind of problematic questions may be asked in the semester examinations. If you have a clear-cut idea about what is the message and how the error is happen and how we are going to detect the errors, then how we are going to correct the error, means it will be easy for us. So these are all the 4 different types of error detection techniques are there. And initially let us discuss about the first error detection technique, that is a single parity check. That is a single parity check. From the name itself we can say that there is only one bit of redundant bit of informations is added with the original message. So we can call it as a parity bit. That's there are 2 different types of parity bits are there. The one is a even parity check and the next one is a odd parity check. So even parity check, it denotes that in your message there will be the number of ones, and it consists of the message is converted is in the form of zeros and ones binary format. So during the, as you know that during the data communications, all the data will be transferred as a binary format, zeros and ones binary format in your machines. While we are sending through the cable transmission medium, it should be converted into the analog signal format. Then it will be with the help of the modem. At the receiver side, we are doing the analog to digital conversion and we are getting the original message. So here the number of bits, the zeros and ones bits, while we are calculating the count of number of ones, if it is a even number, then we can call it as a even parity check. It should be the even number. If it is a odd parity check, means then the number of ones in the message bit should be the odd number. If it is not there, means we have to include additional bit values as a parity bit. Now you can read this content, you can get a clear idea about that. So here that is a redundant bit, we can call it as a parity bit, which is appended at the end of the data unit. So the number of ones becomes even, therefore the total number of transmitted bits would be the 9 bits. So that's a, if we are sending, if your original message consists of 8 bits, then one more bit we have included, that's a 9th bit. The 9th bit value, it may be 0 or 1. So based on the number of counts, number of ones count, then we can keep, we can place either 0 or otherwise 1. So if the number of ones is odd, then the parity bit is 1 we have to include for the even parity check. So this is for even parity check. The total number of ones in the message is odd, means we have to include 1. Instead of that, if it is even, means we have to include 0 as a parity bit value. I hope you can have a clear cut idea about that, how we are going to do the odd parity or even parity. So let us explain with the one small example in the next upcoming slide. This technique generates the total number of ones even. It is called the even parity check. Then the next one is a two-dimensional parity check. So the same kind of concept what we have done it for the single parity check, but the only one difference is two-dimensional parity check. So we can have instead of having a single message bit, we can have a group of message bits we can consider in order to calculate either even parity or odd parity. So that is we have to calculate the parity bit value at both row wise as well as column wise. That is the only one difference is there. So two-dimensional parity check. So here now you can read this content, you can get a clear cut idea about that. Parity bits are computed for each row, which is equivalent to the single parity check. So along with one example, in the next slide we will discuss along with one example. So from that we can have a clear cut idea about that. So two-dimensional parity check, blocks of bits is divided into rows and the redundant bits also added to the whole block. Okay, at the receiver side, we are doing the reverse process. We are removing the parity bits and we are checking the parity bit of at both the sender side and receiver side. We are getting the original data. So this one is an example for that. So this one is a original message, original data. It consists of, there are 4 bits of 4 blocks of data. So the original message consists of 4 blocks of data. So here all the 4 blocks we have written in a row wise. We are calculating the even parity check in row wise. Here 1, 2, 3, 4, 5. So 5 number of ones are there. So our objective is to fit the even parity check. So we have to include one more bit in order to achieve even numbers of ones. So here 1, 2, 3, 4, 5. So one more bit we have included. So 1, 2, 3, 4. So 4 is a even number. So we have to add the 0 bit value here. So here 1, 2, 3. 3 number of ones are there. So in order to achieve even parity, we have to include 1 bit value here. 1 as a additional parity bit. So after that, we have to calculate in the column wise also. The parity check, we have to do it in the column wise also. So here 0, then 1, 2, 3, 4. So 4 is a even number. We have to write it as a 0. Then 1 is an odd number. So we have to include the bit value 1. Then 1, 2, that is a already even number 0. 1, 1, 1, 3 ones are there. So we have to include one more bit value. 1, 2, that's a even number of ones, so include 0, 1, 2, 3. So one more bit value 1 is added, 1, 2. Even number of ones are there, so we have to include 0. So in this way, we can find out the two-dimensional parity check. So in the examinations, there is a possibility to give, you have to find out both single parity as well as two-dimensional parity check by using this given message. Now let us discuss about the next error detection mechanism, that is a checksum. So what is meant by checksum and how we are going to solve that problem? So here it consists of, there are two main parts. One is a checksum generator and the next one is a receiver. At the receiver side, we are going to check whether the error is happened or not. So here the checksum generator is responsible for dividing the whole document data into number of segments in terms of equal number of n bits of informations, datas. So all those segments are added together by using ones complement arithmetic, and at last the sum is complemented and then it will be appended to the original data. It is called the checksum field. So now let us example with one diagrammatical representation. So here we can have a whole message. Whole message is divided into number of segments. So here the section 1, section 2, these are all the segments. We can call it as a segments. So now we are going to find out checksum value. Checksum value denotes that is we have to add the number of n number of bits values. Then after that we are going to calculate the ones complement value. Then after that, at last, finding the sum value, we are going to do the complement of that value. Then we are getting the checksum. That checksum value will be added with the original data. Then it will be sent to the receiver. So at the receiver side also, we have to do the same kind of process what we have done it at the center side. So at the result, we are getting, if we are getting all the bit values are 0, remainder values, resultant values are 0, then we can confirm that there is no error is happened during the communication. If it is not happened, means we can confirmly, we can say that there is a possibility of happening the error. Let us discuss one example. So here you can see that there will be a how many number of, there are 8 blocks of data are there. So original data consists of 32 bits. So here we can set it as a k as a 4, m as a 8. So total number of bits values of each and every segments are 8. How many number of blocks we have considered? 4 blocks we have considered. So at the center side, what we are going to do, that is we have divided into n number of equal blocks of data, and each and every blocks we are going to perform the ones complement. Just we are going to add the two here, the first blocks and second blocks we have written here. Then we are finding the AND operations, that is a XOR operations we are doing. So normal addition operation we are performing. 1 1 0 0 1 0 0 0 0 1 0 1 1 0 1 0 1 1 0 1 1. That is a normal addition. 1 1 1 1 will become 1 0. Okay, so we have written the 0 here, and we can have a remainder value 1. That remainder value will be, that is a, well, will be added with your carry value, will be added with your original data. So now again, once again we are going to add 1 1 means 1 0, 0 is here, then 1 will be added with the already existing 1, 1 1 0. Again 1 bit value is there. So 1 we have written here, and the remaining bits we have written as like that. And then we are going to include that block. Again we are going to do the normal addition. 0 0 0 1 0 1 1 means 1 0. Okay, normal 1 1 means 1 0. So 0 we have added, and the carry bit value 1, 1 plus 1 1 0. So 0 is there, 1 is there, 1 plus 1 1 0, 0, then 1 is there, 1 1 1. There are 3 ones are there. You can assume that there will be 3 ones are there. So normally 3 ones means when we are adding, the resultant value is 1 1. Okay, so அப்போ 1 இங்க வந்துரும். Next வந்து carry bit value 1 will be added here. 1 1 1 1 வந்து என்னது, ரெண்டையும் ஆட் பண்ணோம்னா 1 0. அதாவது 1 1, that's a 1 and 1 we are going to add we are getting the resultant value of 1 0. If it is 1 1 1, 3 ones are there, means we are getting the resultant value of 1 1. Okay. So at last, in the fourth bit value block of data we have included, and at last we are finding the sum value, the resultant value we have sent it to the receiver. That is we are going to perform the ones complement. Yeah. So இதுல வந்து ones complement, how we are going to calculate? Instead of 0, it will become converted into 1. If it is a 1 means 0. Likewise, we are going to calculate. Then that 110111010, this particular checksum value will be added with the added as a fifth block in your original data. Okay. Now you can see that the same kind of process we are performing at the receiver side also. At the end, you can see that this one is the fifth block. That is the original checksum. That checksum value we are going to add, we are going to include. This one is the checksum value. If we are performing the sum operation, we will get all the bit values will become 1. Then while we are doing the complement, it will become 0. All the bit values will become 0. If it is 0 means we can accept the data. There is no error is happen during the communication. So that is a checksum checksum error detection technique. So this one is an example, best example for in order to understand how the process is happen in the communication. And the next error detection technique is a cyclic redundancy check. So here how we are going to perform. So cyclic redundancy check, it performs, that's a string of n number of zeros we are going to include with the original data. Okay. So here we are performing the division functions, we are performing binary division. Then number of zeros is added with the original bit value, original message. Then how we are going to calculate the bit value? Number of zeros means based on the number of divisor, number of bit values in the divisor minus 1. Okay. So that is important. So let us have a discussion along with one example in the upcoming slide. And here this one is a binary division operation we are performing. We can call it as it is divided by the extended data is divided by the divisor using the process called binary division. And the remainder generated from the division is known as CRC remainder. Okay. So at last we are performing the same kind of binary division operation at the receiver side. And if we are getting the 0 as a remainder means we can say that there is no error. If it is not there means we can confirm that there will be a possibility of happening the error. Okay. So that is a thing. And now let us move on to the block representation of CRC cyclic redundancy check error detection mechanism. So here you can see that the original data is added with the CRC cyclic redundancy check. Then we are going to perform the divisor and we are getting the resultant value as a remainder. That if it is 0 means accept, if it is non-zero means we can reject. That will be happen at the receiver side. So sender side what we are doing is we can have a original data, and that original data we can have a divisor, the same kind of process what we have done it here. So divisor, if it is having the n+1 number of bits, so we have to include n number of bits as a CRC bit value. Okay. While we are discussing with that example, okay, number along with one example, then we can get a clarity about that, how they are going to perform. So we are getting the, at last we are getting the remainder. That remainder of bit values will be replaced with that CRC bit value. Yeah. So from the sender side, so that will be sent it to the receiver. At the receiver side, we are performing the reverse process. If we are getting the 0 as a remainder, then that is acceptable. If it is non-zero means we have to reject that. Okay. So this one is the best example for that. So here you can see that the divisor is 1001. So here the original message is 11000000. So here how many number of ones are there? That is here the actual message is 111000. So the divisor number of bits in a divisor value is 4. 1, 2, 3, 4. So how many number of zeros we have to add in the original message is 3. That is a 4 minus 3 minus 1. 4 minus 1, that is a 3. So 3 number of zeros we have added. So this one is a additional bits, CRC bit value we have included with the original message. Now we are going to perform the ordinary binary division. So இங்க என்ன பண்ணுவோம்னா we are going to calculate the XOR function. Perform the XOR function. XOR function எப்படி இருக்கும்? If it is equal, then that is 0. If it is different, then we have to put it as 1. For example, 0, 0 means 0, 1, 1, 0, 0, 1 means 1, 1, 0 na 1. If both the bit value 0, 1, 1, 0, then we have to type it as 1. Now let us discuss about that. Here 0, 1, that is different. Different means we have to type it as 1. Different 1, different 1. So here the same, 1, 1 means 0. So 0 is there, just we have to neglect that 0. Okay. Then again we are going to perform, so 1. Again we are doing the same kind of function. 0 அப்படியே கீழே இறக்குறோம், மறுபடி 1, 0, 0, 1 வருது. Again we are performing the action. At last இதே மாதிரி perform பண்ணும்போது at last we are getting the resultant value of 111. Okay, 111 as a reminder that 3 ones will be replaced with 3 zeros. Okay, இதுல replace பண்ணிட்டு நேரா சென்டர் ரிசீவருக்கு வந்து we will transmit. Now you can see that instead of zeros it has been modified as 111. The same kind of process, the reverse, that is the same kind of binary division we are going to perform at the receiver side. We are getting the resultant value of 000 as a reminder. So from that we can confirm that there is no error communication is there. There is no error is happened during the data communication. So that is a one kind of error detection mechanism. Okay, so I hope you can have a clarity about that. How this one is an actual explanation for what we have discussed in this diagrammatical representation. Okay, நம்ம என்ன பார்த்தோமோ அதே தான் இங்கே கொடுத்துருக்காங்க. So this one is the original data, original message. That message it consists of 3 number of zeros we have incorporated here. So division, at last remainder value we are getting 111. That will be added with the original data. Then it will be sent to the receiver. At the receiver side we are performing the same modulo to division function, and if we are getting the remainder value as 0 means that is acceptable. If it is not, then we should not accept it. Okay, so I hope you can have a clarity about. So in this presentation we have discussed about what is meant by successful data communication, what is a main impact of happening error in the data communication. We have covered different types of errors, single bit error, burst error, then different types of error detection techniques we have covered, like single parity bit, then 2-dimensional parity bit checking, then checksum error detection method, then CRC error detection method. So thank you for watching this video. Thank you.